Welcome back to the Taakif channel. We have studied the interior of the Earth, the drifting continents, and the minerals that make up our rocks. Now, we arrive at the surface. Today we dedicate ourselves to the visible face of our planet in Chapter 7, Landforms and Their Evolution. Look out your window. Whatever landform you see, a hill, a plain, a valley, did not always look this way, and it will not look this way in the future. The surface of the Earth is a stage where a great drama is being enacted. The actors in this drama are the geomorphic agents, running water, groundwater, glaciers, wind, and waves. The plot of this drama is evolution. What do we mean by evolution in geography? It implies that every landform has a history. It has a beginning, a youth, a maturity, and an old age. Just as a human face changes wrinkles and lines over a lifetime, the face of the Earth changes its valleys and ridges over eons.
To understand any landform, we must ask three fundamental questions. 1. Structure. What is it made of? Is the rock hard or soft, folded or faulted, permeable or impermeable? 2. Process. Which agent is working on it? Is it the chemical touch of groundwater or the brute force of a glacier? 3. Stage. How long has this been happening? Is the landform young and jagged or old and rounded? In this comprehensive session, we will break down the work of the 5 major agents. We will examine how they erode the land, degradation, and how they build the land, aggradation. We begin with the most important geomorphic agent on the Earth's land surface, running water. In humid regions, which receive heavy rainfall, running water is dominant. But how does it start? It begins with overland flow. Imagine a heavy downpour. The soil gets saturated. The excess water forms a thin sheet over the land surface. This sheet flows down the slope. Depending on the irregularities of the ground, this sheet concentrates into small parts. These parts cut small rills. The rills merge to form gullies. The gullies deepen and widen to form valleys.
A river is not the same throughout its journey. We generally divide the life of a river into 3 distinct stages: youth, maturity, and old age. 1. The youth stage. Picture a river high in the mountains. The streams are few, the integration is poor. Here, the river is aggressive. It flows over steep V-shaped valleys. There are no floodplains or they are very narrow. The river is busy down-cutting, eroding vertically into the bedrock. Because the gradient is steep, you will find rapids and waterfalls here. 2. The mature stage. As the river leaves the mountains, it enters maturity. It has many tributaries, the volume of water increases. The valleys get wider and deeper. The V-shape broadens. Waterfalls and rapids disappear. The river begins to swing from side to side, creating large loops called meanders. Floodplains begin to develop inside the valley. 3. The old stage. Finally, the river reaches the lowlands. The tributaries are few. The landscape is a vast flat plain. The river flows gently. It meanders freely. It leaves behind oxbow lakes. The work of the river shifts almost entirely to deposition. It builds up the land rather than cutting it down. Erosional landforms of running water. Let us look closely at the specific sculptures carved by running water. A. Valleys. Valleys start as small rills and grow into gullies. Depending on the dimensions, we distinguish between a gorge and a canyon. A gorge is a deep valley with very steep straight sides. The width at the top is almost equal to the width at the bottom. Gorges usually form in hard rocks. A canyon is also deep, but it is characterized by steep step-like side slopes. A canyon is wider at the top than at the bottom. The Grand Canyon is the classic example, formed in horizontal sedimentary rocks. B. Potholes and plunge pools. Look at the rocky bed of a hill stream. You might see circular depressions. These are potholes. They form through abrasion. The water swirls pebbles around in a small depression. These pebbles act like a drill, grinding deeper and deeper into the rock. When these potholes merge, they deepen the stream channel. At the foot of waterfalls, the force of the falling water creates massive potholes called plunge pools. These pools undercut the waterfall, causing it to collapse and retreat backward over time.
C. Incised or entrenched meanders. Usually, meanders form on flat floodplains, but sometimes we find deep, wide meanders cut hard into the bedrock. These are called incised meanders. This happens when a river is rejuvenated. Perhaps the land rose up, upliftment, forcing the mature river to start cutting vertically again like a young river. D. River terraces. Look at the sides of a valley. Do you see steps or benches? These are river terraces. They mark the level of former floodplains. They show us where the river used to flow before it cut down deeper. If the terraces on the left and right banks are at the same elevation, we call them paired terraces. If they are at different heights due to slow shifting, they are unpaired terraces. Depositional landforms of running water. When the river slows down, it loses the kinetic energy needed to carry its load. It begins to build. A. Alluvial fans. Imagine a stream rushing out of a steep mountain gorge onto a flat plain. It suddenly loses speed. It dumps its heavy load of coarse boulders and sand in a cone shape. This is an alluvial fan. The stream often gets blocked by its own debris and splits into many channels called distributaries. In humid areas, these fans have low cones. In arid areas, they are steep.
B. Deltas. A delta is like an alluvial fan, but it forms where the river enters the sea. Here, the deposits are sorted. The heaviest material settles first, and fine clay is carried furthest into the sea. As the delta grows layer by layer, the river extends into the ocean. C. Floodplains and natural levees. A floodplain is the major landform of river deposition. During floods, water spills over the banks, carrying fine sediment, sand, silt, clay. It deposits this sheet of soil over the valley floor. However, the coarsest, heaviest material is dropped right next to the river channel. This builds up low linear ridges along the banks called natural levees. These levees are helpful in containing the flow, but if they breach, the flooding is catastrophic. D. Meanders and oxbow lakes. A meander is a loop. As water flows around a bend, it moves faster on the outside of the curve and slower on the inside. Outer bank, active erosion creates a steep cut bank. Inner bank, slow water deposits sand, creates a point bar. Over time, the loop becomes more extreme. Eventually, the river cuts through the narrow neck of the loop, leaving the curve behind as a detached body of water, an oxbow lake. E. Braided channels. When a river carries a very heavy load but has a low volume of water, it cannot transport all the sand. It deposits islands, sandbars, in the middle of its own channel. The water is forced to split and rejoin around these islands, looking like a braid of hair. Groundwater, the chemical sculptor. We now move underground. Here, the geomorphic agent is groundwater. Unlike rivers, groundwater does not erode by mechanical force. It erodes by chemical solution. This process works best in rocks rich in calcium carbonate like limestone or dolomite. This creates a unique landscape called Karst topography. Erosional landforms. 1. Swallow holes. Small openings on the surface where streams disappear underground. 2. Sinkholes. Funnel-shaped depressions. If the bottom is formed by solution, it is a solution sink. If the roof of a void collapses, it is a collapse sink or doline. 3. Uvala. When sinkholes merge together to form a large, long depression. 4. Lapis. In areas where limestone ridges are eaten away by water, leaving behind jagged, sharp, trench-like ridges. 5. Caves. Voids created underground where alternating beds of hard and soft rocks exist.
Depositional landforms. Inside the caves, the water drips from the ceiling. As it evaporates, it leaves the calcium carbonate behind. Stalactites. These grow downwards from the roof. They are often thin and icicle-shaped. Stalagmites. These grow upwards from the floor, formed by the water dripping from the stalactites. They are usually broader. Pillars. When a stalactite and stalagmite meet and fuse, they form a solid pillar. Glaciers.
The moving ice. A glacier is a mass of ice moving under its own weight. It is an extremely powerful eroding agent. It moves slowly, but its mass gives it incredible force. Glaciers erode in two ways. 1. Plucking. The ice freezes onto the rock and pulls blocks out as it moves. 2. Abrasion. The rock debris frozen at the bottom of the glacier acts like sandpaper, polishing the valley floor. Erosional landforms. Cirque, the most common landform. It is a bowl-shaped depression found at the head of a glacial valley. It looks like an armchair with steep walls. When the ice melts, water fills it to form a cirque lake or tarn. Horns. When three or more cirques cut back into a mountain peak from different sides, they sharpen the peak into a high-pointed spire called a horn. Arêtes. These are sharp serrated ridges separating two glacial valleys. Glacial valleys, troughs. Unlike river valleys, which are V-shaped, glacial valleys are U-shaped. They are broad, deep, and have flat floors. Depositional landforms. When the glacier melts, it drops the debris it was carrying. This unassorted debris is called till. Moraines. These are ridges of till. Terminal moraines mark the furthest point the glacier reached. Lateral moraines, deposits along the sides of the glacier. Medial moraines, when two glaciers merge, their lateral moraines join in the center. Eskers, these are very specific. In summer, water flows inside the glacier through tunnels. It deposits gravel in these tunnels. When the ice melts, these deposits remain as long, winding ridges. Drumlins, smooth oval-shaped hills made of glacial till. They look like an inverted spoon or a basket of eggs. The steep side faces the direction the ice came from. The gentle slope points in the direction of flow.
Waves and winds. Waves and currents, along with wind, are powerful geomorphic agents that reshape the Earth's surface through the processes of erosion and deposition. While waves act as the primary sculptor of the world's coastlines, wind is the dominant force in arid and semi-arid desert environments where vegetation is sparse. Waves and currents, coastal landforms. Coastal processes are among the most dynamic geomorphic activities, often resulting in rapid changes to the landscape. Most of the work performed by waves is concentrated at the boundary where the sea meets the land. Classification of coasts. Coasts are broadly categorized into two types based on their evolution. High rocky coasts, these are typically emerging coasts where the land is retreating. The shoreline is highly irregular and marked by steep slopes diving into the sea. Low sedimentary coasts, these are generally submerging coasts or areas where rivers have extended the land into the sea. The shoreline is smooth and characterized by gentle slopes.
Erosional landforms of waves. 1. Cliffs. Waves strike the base of high rocky coasts, creating a notch through constant impact. Over time, the rock above the notch collapses, forming a steep vertical face known as a cliff. 2. Wave-cut terraces. As waves continue to erode the base, the cliff retreats further inland. This leaves behind a flat rock floor at the foot of the cliff, which is called a wave-cut terrace. 3. Sea stacks. Sometimes, harder portions of rock resist erosion better than the surrounding material. These isolated rock columns left standing in the water as the coastline has retreated are called sea stacks. Depositional landforms of waves. 1. Beaches. These are temporary accumulations of sand, gravel, or pebbles along the shore. Sediment is moved and sorted by wave action, often shifting seasonally. 2. Bars and spits. A bar is a ridge of sand or shingle formed in the sea, running parallel to the coast. If one end of the bar is attached to the mainland, it is called a spit. 3. Lagoons. When a bar grows across a bay, it traps a portion of the seawater behind it, creating a shallow body of water known as a lagoon.
Wind, arid landforms. In hot deserts, wind is the most significant geomorphic agent. Because deserts lack a protective cover of vegetation, the ground is exposed to the full force of the wind, which moves weathered debris through deflation, lifting and blowing away fine particles, and abrasion, sandblasting rock surfaces. Erosional landforms of wind. 1. Pediments and pediplains. Wind and water work together to wear down high-relief structures. Gently sloping rock floors at the foot of mountains are called pediments, which eventually merge over vast areas to form near-featureless plains called pediplains. 2. Deflation hollows. Persistent wind blowing in one direction can lift and remove loose sand from the ground, creating shallow depressions called deflation hollows. 3. Mushroom rocks. Wind-blown sand is heavy and remains concentrated near the ground. Consequently, abrasion is most intense at the base of standing rocks, wearing them down more than the top. This results in a rock that looks like a mushroom, with a narrow stem and a broad cap. Depositional landforms of wind. When wind velocity decreases or it encounters an obstacle, it drops its load of sand to form dunes. Number 1. Bergchans. These are the most common dunes. They are crescent-shaped with horns or points that face downwind in the direction the wind is blowing. Number 2. Parabolic dunes. These are also crescent-shaped but form in areas where sand surfaces are partially covered by vegetation. Their points face upwind, the opposite direction of bergchans. Number 3. Seef dunes. These are longitudinal dunes that resemble a bergchan but have only one wing or point. They occur when wind directions shift slightly. Number 4. Transverse dunes. These are long ridges of sand that align perpendicular to the constant direction of the wind. Number 5. Longitudinal dunes. These form as long, narrow ridges that align parallel to the direction of the wind and occur when sand supply is limited. If you found this strategic overview helpful, please like, subscribe, and share this journey with your fellow aspirants. If you have any questions regarding what we have discussed today, drop a comment below. I will be personally addressing your doubts to ensure your conceptual clarity is absolute. Until next time, keep studying, stay curious, and I will see you in the next lesson.